Hello everyone. Today we'll be looking at Cambridge International AS and A Level Pure Mathematics 1 9709/12 May June 2021. The first question is express 16x square minus 24x plus 10 in the form 4x plus a the whole square plus b. So we have to express 16x square minus 24x plus 10 in a plus b the whole square format. Okay. So 16x square can be written as 4x the whole square. Okay. Now the a value is 4x. So 2 multiplied by 4x multiplied by, okay, 2 multiplied by 4x multiplied by what number gives 24? It is 3. 2 multiplied by 4x is 8x. 8x multiplied by 3, you will get negative 24x. Okay. So now we have to add and subtract 3 square plus 10. Okay. This is of the form 4x minus 3 the whole square. Negative 3 square is negative 9 plus 10 is plus 1. So the next part of the question is, it is given that the equation 16x square minus 24x plus 10 equal to k, where k is a constant, has exactly one root. Find the value of this root. Okay, it's given it has exactly one root. That means the square term will be equal to 0. So that is 4x minus 3 the whole square should be equal to 0. Then only it will have one root. Okay, so the k value will be 1. So 4x minus 3 the whole square plus 1 equal to k. So it has exactly one root. That means 4x minus 3 the whole square should be equal to 0. So k is equal to 1. Then only you will get 4x minus 3 the whole square equal to 0. Okay. So now we have to find that root also. So 4x minus the whole square equal to 0 can be written as 4x minus 3 equal to 0. Or x equal to 3 over 4. Next, question number 2. The graph y is equal to f of x is transformed to the graph of y is equal to 2 multiplied by f of x minus 1 the whole square. Describe fully the two single transformations which have been combined to give the resulting transformation. So y is equal to 2 multiplied by f of x minus 1. So first whatever inside the bracket, we have to do that transformations. So it is x minus 1. That means translation along the x-axis by 1 unit. Okay, and the vector is 1, 0. So this is the first transformation. Okay, next it is 2 multiplied by f of x minus 1. So that is nothing but a stretching along the y-axis with the factor 2. Next part of the question is the curve y is equal to sine 2x minus 5x is reflected in the y-axis and then stretched by a scale factor 1 over 3 in the x direction. Write down the equation of the transformed curve. Okay. First, it's given it is reflected in the y-axis. Okay. So you have to write y is equal to minus of sine 2x minus 5x. So y is equal to minus sine 2x plus 5x. Okay. Next, it is stretched by a scale factor 1 over 3. So x will be replaced by or x is multiplied by 1 over 3, reciprocal of 1 over 3. So you will get minus sine 2 multiplied by 3 is 6x plus 5 multiplied by 3, that is 15x. So this is the equation of the transformed curve. Next, question number 3. The equation of a curve is y is equal to x minus 3 multiplied by square root of x plus 1 plus 3. The following points lie on the curve. Non-exact values are rounded to 4 decimal places. Okay, A, B, C, D, E values are given. Find K, giving your answer correct to 4 decimal places. So it's given the following points lie on the curve. So that means all the points satisfies the equation. So the point A also lie on the curve. So it will also satisfy the equation. So we will write y is k. So k is equal to x minus 3. X is 2. 2 minus 3 multiplied by square root of 2 plus 1 plus 3. Okay, on simplification, this gives 1.2679 after correcting to 4 decimal places. So this is the value of k. Next part of the question is find the gradient of AE, giving your answer correct to 4 decimal places. So AE, y2 minus y1 is 3 minus 1.2679. So this is the coordinate of E, 2 comma 1.2679 divided by 3 minus 2 equal to, and this is also correct to 4 decimal places, 1.7321. Okay, this is the gradient of A. Next part of the question is the gradients of BE, CE and DE rounded to 4 decimal places are 1.9748 and 1.9975 and 1.9997 respectively. State, giving a reason for your answer, what the value of 4 gradients suggests about the gradient of the curve at the point E. Okay, so you can see all the 3 and A is also 1.73. Okay, when you round up, all are giving the answer 2. Okay, so it converges to 2. So gradient of the curve at the point is 2. So the gradient of the curve at E is approximately 2. Next, question number 4. The coefficient of x in the expansion of 4x plus 10 over x the whole cube is p. The coefficient of 1 over x in the expansion of 2x plus k over x square the whole power 5 is q. Given that p is equal to 6q, find the possible values of k. So it is a binomial expansion question. Let's write the general term for the first expansion. So 3c, so we have to get the coefficient of x. Okay, 3cr 4x power r 10 over x power 3 minus r. Okay, so we need to get the coefficient of x. So we'll equate the r powers. So x power r and x power minus 3 plus r equal to x power 1, because we need the coefficient of x only. So the power is 1. So when the base are same, you can add the power and equate the power because bases are same. So r minus 3 plus r equal to 1. So 2r is equal to 4. So r is equal to 2. So substitute r is equal to 2 in the expansion. So you will get 3c2 4x power 2 multiplied by 10 divided by x the whole power 3 minus r. 3 minus 2 is 1. Okay, so now you will get the coefficient of x, which is p. So p is equal to 3 multiplied by 16. 4 square is 16 multiplied by 10. So which is equal to 480. So p is equal to 480. Okay. So from this expansion, find the coefficient of 1 over x. Okay. For that expression, the general term is 5cr 2x power r k divided by x square the whole power 5 minus r. So x power r multiplied by x square. Okay, when it comes to the numerator, you will get x power minus 2 multiplied by 5 minus r. So minus 10 plus 2r equal to 1 over x is x power minus 1. Okay. Now equate the powers. R minus 10 plus 2r equal to negative 1. So 3r equal to 9. So r equal to 3. So substitute r is equal to 2, r equal to 3 in this case. So 5c3 2x power 3 multiplied by k over x square. The power is 5 minus 3, which is nothing but 2. Okay. So it's given the coefficient of 1 over x in this expansion is q. So q is equal to 10 multiplied by 2 cube is 8 multiplied by k square. So 80 k square. So q is equal to 80 k square. So it's given p is equal to 6q. So p is 480. Q is equal to, okay, p is equal to 6q. 80 k square. So k square is 480 divided by 6 multiplied by 80 is 1. So k is equal to plus or minus 1. Next, question number 5. The function f is defined by f of x equal to 2x square plus 3 for x greater than or equal to 0. Find and simplify an expression for f of x. So f of x. Okay. So for x you had to substitute 2x square plus 3 square plus 3. Okay. Now we have to expand this one. 4x power 4 plus 9 plus 12x square plus 3. So it gives 8x power 4 plus 24x square plus 18 plus 3. So f of x equal to 8x power 4 plus 24x square plus 21. So the next part of the question is solve the equation f of x equal to 34x square plus 19. Okay. From the previous question's answer, 8x power 4 plus 24x square plus 21 is the value for f of x. We'll substitute here, which is equal to 34x square plus 19. So now we have to solve this one. So bring all the term into one side. So 8x power 4. When 34x comes this side, you'll get negative 34. So you'll get negative x square. 21 minus 9 is plus 2 equal to 0. Okay. Now solve this equation by using a quadratic formula. So x square equal to 10 plus or minus b square is 100 minus 4 multiplied by 8 multiplied by 2 divided by 2 multiplied by 8. So you'll get 10 plus or minus square root of 100 minus 4 multiplied by 8 multiplied by 2 is 64. So you will get 36. Square root of 36 is 6 divided by 16. So x square equal to 10 plus 6 is 16 over 16, 1. Or x square equal to 10 minus 6 is 4. 4 over 16 is 1 over 4. So x equal to plus or minus 1 or x equal to plus or minus 1 over 2. So these are the 4 solutions. Next, question number 6. Points A and B have coordinates 8, 3 and P, Q respectively. The equation of the perpendicular bisector of AB is y is equal to minus 2x plus 4. Find the values of P and Q. So A and B coordinates are given 8, 3. So this is A and B is P, Q. So this is the midpoint perpendicular bisector. Okay, this equation is y is equal to minus 2x plus 4. This is the midpoint of A and B. So first we will find out what is the midpoint of A and B. Midpoint of AB is P plus 8 divided by 2, comma Q plus 3 divided by 2. Okay. So next we will find out the gradient of AB and the gradient of the line which is perpendicular to AB. So the gradient of AB, is Q minus 3 divided by P minus 8, and we know the gradient of AB is nothing but from the perpendicular bisector we can get the gradient. It is minus 1 over minus 2, that is 1 over 2. Okay, let us simplify this one. 2q minus 6 equal to P minus 8. So minus P plus 2q equal to negative 2. So let us mark this as 1. And we found the midpoint of AB. So this point which lies on AB as well as the perpendicular bisector. So it will satisfy the perpendicular bisector equation. So y is equal to, so we'll substitute P plus Q divided by 2, comma Q plus 3 divided by 2 in y is equal to minus 2x plus 4. So Q plus 3 divided by 2 is equal to negative 2 multiplied by P plus 8 divided by 2 plus 4. This 2 get cancelled. You will get Q plus 3 is equal to minus 2P minus 16 plus 8. So 2P plus Q is equal to minus 16 plus 8 minus 3 is minus 11. Okay, let us mark this as 2. So now we got two simultaneous equations. So we can solve these two equations. So 2P plus Q is equal to negative 11. Equation 1 we will multiply by 2. So we will get to negative 2p plus 4q negative 4. When you add, you will get 5q equal to minus 1 5. So q is equal to negative 3. Okay. So substitute q is equal to negative 3 in equation 1. You will get p is equal to minus 2 minus 2q. So p is equal to minus 4. So p is equal to minus 4 and q is equal to 3, negative 3. Next, question number 7. The point A has coordinates 1, 5 and the line L has a gradient negative 2 over 3 and passes through A. A circle has center 5, 11 and radius square root of 52. Show that L is the tangent to the circle at A. For this, first we will find out what is the gradient of the circle at A. Suppose this is the circle and this is the point A. So if you join the point of contact of the tangent and the circle with the center of the circle, it will make 90 degree. Okay. So for that, first we will find out the gradient of the circle at A. It is 11 minus 5 divided by 5 minus 1, which is equal to 6 over 4. So 3 over 2. Now we will find out what is the gradient of the line L. Okay, it is given already. It has the gradient negative 2 over 3. Okay, if both are perpendicular, then the gradient product of their gradient will be negative 1. So the gradient of the circle at A is 3 over 2 and the gradient of L is negative 2 over 3. Okay, this gives negative 1. That means the line L and the line drawn from the center of the circle to the point of contact are perpendicular. So the line perpendicular to the radius from the center of the circle is a tangent. So the line perpendicular to the radius from the center of the circle is a tangent. Next part of the question is find the equation of the other circle of radius square root of 52 for which L is also the tangent at E. This is the point A. So we had to find the equation of the other circle for which L is also the tangent at A. So this will be the another circle for which L is also the tangent at A. Okay. So the center of the other circle is, so this is the center is 5, 11, and A is 1, 5. Okay. See, suppose this is 5, 11, and this is A 11, 5. Okay, 1, 5. So we have to find out this center. Okay. So the distance from C1 to A is same as the distance from A to C2. Okay. So A is like a midpoint of C1 and C2. So we can find out C2 as from 5 to 1. If you subtract -4, you will get 1 from 5. So from 1 you have to subtract 4. So you'll get -3. From 11, 5. So my 11 minus 6 is 5. So 5 minus 6 is -1. So this is the C2 value, that is the center of the other circle, and the radius is given square root of 52. So the center of the other circle is -3, -1. Now we will write the equation of the other circle. So the equation of the other circle is x minus of -3, so +3, plus y minus of -1, so y plus 1, the whole square equal to, radius is 52, square root of 52. So here we have to write r square, that is 52. Square root of 52, the whole square will give square root 52. Next, question number 8. The first, second and third terms of an arithmetic progression are a 3 over 2a and b respectively, where a and b are positive constants. The first, second and third terms of a geometric progression are a 18 and b plus 3 respectively. Find the values of a and b. So in the arithmetic progression, the first term is a and the second term is a plus d, which is equal to 3 over 2a, and the third term is a plus 2d, which is equal to b. Okay. So in geometric progression, the first term is a and the second term is 18. So that is AR equal to 18, AR square equal to B plus 3. In arithmetic progression, from the second and third equation, second and third term, multiply 1 by 2. So you'll get 2a plus 2d equal to 3a. A plus 2d equal to b. If you subtract, you will get 2a minus a is a, 3a minus b. Okay. So this gives minus, okay, 2a is equal to b. From here, find out R value. It gives R equal to 18 over A. So substitute in equation 3. So you will get A multiplied by 18 square by A square equal to B plus 3. So 18 square equal to A multiplied by B plus 3. So 18 square is 324 equal to A. For B value, you substitute 2A. So 324 minus 2A square minus 3A equal to 0. Or this can be written as 2A square plus 3A minus 324 equal to 0. Solve this using quadratic formula. So A is equal to minus 3 plus or minus 9 minus 4 multiplied by 2 multiplied by 324. So this will become positive by 2 multiplied by 2. So A is equal to 12 comma negative 13.5. So these two value will get, because it's given A and B are positive constant, so we are taking A as 12. Since A is positive, we take A is equal to 12. So B is equal to 2A. So B is equal to 2 multiplied by 12, which is nothing but 24. So A is equal to 12 and B is equal to 24. Next part of the question is find the sum of the first 20 terms of the arithmetic progression. Okay. So the formula is S20 equal to N divided by 2 multiplied by 2A plus N minus 1 multiplied by D. So here we know the value of A, we have to find out the value of D. So from equation 1, we will find out the D value. D is equal to 3 over 2A minus A. Which is equal to A over 2. So 12 over 2 gives 6. So D is equal to 6. So S20, sum of first 20 term equal to N over 2. So 20 over 2 multiplied by 2 multiplied by A value is 12 plus N minus 1 is 19 multiplied by D is 6. So on simplification, this gives 1380. Next, question number 9. The diagram shows part of the curve with equation y square equal to x minus 2 and lines x equal to 5 and y is equal to 1. The shaded region enclosed by the curve and the lines is rotated through 360-degree around the x-axis. Find the volume obtained. So to find the volume of the shaded region enclosed by the line, we have to find out this x value. So here the y value is 1. So in the equation y squared equal to x minus 2, substitute y is equal to 1, which gives x value as 3. Okay. So to find the volume, we have to integrate. The formula is pi integral, and the limit here is 3 to 5 y square dx. Okay, to find the area enclosed by the shaded region, so which is nothing but the curve minus the line equation. So y square is x minus 2. From this you have to subtract the line, area under the line. So which is nothing but y is equal to 1. So y square is 1 square. So dx. Now we will integrate this one. X square divided by 2 minus 2 minus 1 gives minus 3. So minus 3 on integration, this gives 3x. So pi 5 square divided by 2 minus 3 multiplied by 5 minus 3 square over 2 plus 3 multiplied by 3. On simplification, this gives pi multiplied by 2, which can be written as 2 pi. Next, question number 10. Prove the identity 1 plus sin x divided by 1 minus sin x minus 1 minus sin x divided by 1 plus sin x equal to 4 tan x over cos x. Okay. We will find the common denominator first. So 1 minus sin x multiplied by 1 plus sin x. 1 plus sin x multiplied by 1 plus sin x. Okay. So 1 plus sin x plus sin x plus sin square x minus 1 minus sin x multiplied by 1 minus sin x. So 1 minus sin x minus sin x plus sin square x. So this gives 1 minus 1 get cancelled. 2 sin x plus 2 sin x. So 4 sin x sin square x minus sin square x gets cancelled. This is divided by 1 minus sin x multiplied by 1 plus sin x gives, it is like a minus b multiplied by a plus b, which gives a squared minus b square. So 1 square minus sin square x. Okay. And we know 1 minus sin square x is nothing but cos square x. 4 sin x divided by cos square x. From cos square x, combine 1 cos x with the sin x, you will get tan x. So 4 sin x divided by cos x multiplied by cos x. Okay. So if you combine this one, you will get 4 tan x divided by cos x, which is our right hand side. Hence solve the equation 1 plus sin x divided by 1 minus sin x minus 1 minus sin x divided by 1 plus sin x equal to 8. So from the previous part of the question, we got the answer as 4 tan x by cos x. 4 tan x divided by cos x equal to 8 tan x. Bring the tan x to the left hand side, so you will get, and take it commonly also, tan x 1 over cos x minus 2 equal to 0. So 4 tan x equal to 0, that is tan x 0 or 1 minus cos x minus 2 equal to 0. So that means cos x equal to 1 over 2. So tan inverse of 0 is, so x equal to tan inverse of 0, which is nothing but 0. Okay, here x equal to, so the range is given 0 to pi over 2. So we have to write in radians. So pi over 3. So x equal to 0, and one more solution is x equal to pi over 3. Next, question number 11. The gradient of a curve is given by dy by dx equal to 6 multiplied by 3x minus 5 the whole cube minus kx square, where k is a constant. The curve has a stationary point at 2, negative 3.5. Find the value of k. The curve has a stationary point at 2, negative 3.5. That is dy by dx we need to find at the point 2, negative 3.5. So at 2, 3.25, or we can just write x equal to 2. 6 multiplied by 3 multiplied by 2 minus 5 the whole cube minus k multiplied by 2 square equal to 0, because it's a stationary point, so dy by dx is 0. So this is nothing but 6 minus 5 is 1 cube gives 1. So 6 minus 4k equal to minus 6. So k is equal to 3 over 2. Find the equation of the curve. To find the equation of the curve, we have to integrate this dy by dx value. Okay, so you will get y is equal to integral 6 multiplied by 3x minus 5 the whole cube minus 3 over 2 x squared. 3 over 2 is the value of the k. This you have to integrate. 3x minus 5 the whole power 4 divided by 4 multiplied by 3 minus 3 over 2 multiplied by x cube divided by 3. plus C. So on simplification, 6 divided by 4 multiplied by 3 is 1 over 2. 3x minus 5 the whole power 4 minus 1 over 2 x cube plus C. Okay. So we'll substitute 2 comma negative 3.5 here to find the value of C. Three multiplied by 2 minus 5 the whole power 4 minus 1 over 2 multiplied by 2 cube plus C. Negative 3.5 equal to half multiplied by 3 multiplied by 2 is 6. 6 minus 5 is 1. 1 power 4 is 1. So half multiplied by 1 minus half multiplied by 2 cube is 8. 8 divided by 2 gives 4 plus C. Half minus 4 gives negative 3.5. When it goes to other side, it will become positive. So both gets cancelled. So C is equal to 0. So y is equal to 1 over 2 multiplied by 3x minus 5 the whole power 4 minus 1 over 2 x cube. Next part of the question is find d square y by dx square. D square y by dx square equal to 6 multiplied by 3 multiplied by 3x minus 5 the whole power 2 multiplied by 3 minus 3 over 2. So x squared will become 2x. 54 multiplied by 3x minus 5 the whole square minus 3x. Okay, we will expand this. 54 multiplied by 9x square minus 30x plus 25 minus 3x. 486 x square minus 1623x plus 1350. Next part of the question is determine the nature of the stationary point at 2 comma negative 3.5. So we have to substitute this in d square y by dx square. So at x equal to 2. You substitute here. So x is 2. 3 multiplied by 2 is 6. 6 minus 5 is 1. 1 square is 1. So 54 multiplied by 1 square is 54 minus 3 multiplied by 2, which gives a positive value, that is 48, which is greater than 0. So it's a minimum point. Next, question number 12. The diagram shows a cross section of 7 cylindrical pipes, each of radius 20 cm, held together by a thin rope which is wrapped tightly around the pipes. The centers of the 6 outer pipes are A, B, C, D, E and F. Points P and Q are situated where straight sections of the rope meets the pipe with center A. Show that angle PAQ is equal to 1 over 3 pi radians. So angle in a circle is 2 pi. Because it's given in radians, we will take it as 2 pi. We can see it is divided into 6 equal parts. So the angle PAQ will be 2 pi divided by 6. So angle PAQ is 2 pi by 6, which is nothing but pi over 3 radians. Find the length of the rope. So to find the length of the rope, we will join here. Okay. The distance between A and B is A and B are the center of the circle. So it will be 2 times the radians. So I'll mark this as Q dash. The distance from Q to Q dash is 40 centimeter. Okay. And similarly, in all the other side also, we will get 40, 40 like that. So 6 times we will get 40. Next, we have to find the arc length here. So that also we have 6 arc lengths, similar arc lengths. So 6 times arc length of PQ. So length of the rope equal to 6 multiplied by 20 plus 20 plus 6 times arc length of PQ, which gives 240 plus 6 times arc length is r theta. So 20 multiplied by pi over 3, which gives 40 pi. We can leave up to this, or I can simplify. This gives 366 centimeter. Next part of the question is find the area of the hexagon ABCDEF, giving your answer in terms of square root of 3. So we'll first join all the centers. Okay. If you joined F and C, we will get two identical trapezium. We know the area of a trapezium. Okay, so the distance AB is 40 centimeter. This is 40 centimeter. And FC is 20, 40, 20, 80 centimeter. But we need the height. Okay, from B to here. This is a right angle triangle. And this distance is 20. So the BC distance is 40. We have to find out the perpendicular length. So since it's a right angle triangle, we can use the Pythagoras theorem. So this length is square root of 40 square minus 20 square. Okay, which is equal to 20 square root of 3. So the area of the hexagon ABCDEF is 2 times the area of the trapezium ABCF. Okay. So this is equal to 2 multiplied by area of the trapezium is 1 over 2 multiplied by A plus B. That is 40 plus 80 multiplied by the height. Height is 20 square root of 3. Okay. So 2 gets cancelled. 40 plus 80 is 120 multiplied by 20 and square root of 3. So 400 multiplied by square root of 3. So this is the total area of the hexagon ABCDEF in centimeter square. Next part of the question is find the area of the complete region enclosed by the rope. So total area we can find. So this is the hexagon. We found the area of the hexagon in the previous part of the question. Okay. And the remaining side PAQ is a sector. And next we have a rectangle. So from the previous part of the question, we found the area of the hexagon. Okay. And we have to find the area of the sector PAQ. 6 sectors we have. Then we are having 6 rectangles AB, Q, Q dash, similar rectangles. So we have to find the area of the rectangles. So area of the sector, 6 area of the sector plus 6 times the area of the rectangle plus the hexagon area gives the complete region enclosed by the rope. So the total area is equal to 6 times the area of the sector PAQ plus 6 times the area of the rectangle AB Q dash Q plus area of the hexagon. So area of the sector is 6 multiplied by area of the sector 20 square multiplied by pi over 3. That's the angle plus 6 times area of the rectangle is the distance AB is 40 and QA is 20 plus area of the hexagon is 2400 multiplied by square root of 3. So on simplification, this gives 10213.56 centimeter square. Okay. So this is approximately 10200 centimeter square 2SF.